Imagine this. You wake up on the morning of October 20th, 2025. You grab your phone to check your messages, maybe you try to play a game, or you ask your smart speaker to turn on the lights, and nothing. Just silence. For millions of people, this wasn't some bad dream. It was the day a huge slice of the internet just vanished. And this wasn't just a glitch on your phone. It was a deep crack in the very foundation of the internet. So let's dig into what really happened.
So the first signs that something was terribly wrong weren't, a single big crash. It was more like this creeping wave of failures, hitting all these services that, at first glance, seemed to have absolutely nothing to do with each other.
For most of us, the first clue was a website called Down Detector. You know the one. It tracks when things go offline. Well, on this day, it just exploded in a sea of red. Report after report started flooding in. This wasn't just one app having a bad day. It felt more like a digital pandemic.
And just look at the list. It's all over the place. You've got social media, you've got massive games like Fortnite and Roblox kicking millions of players out mid-game, you've got learning apps, creative tools, even your smart doorbell stopped working. And this is the critical part. Major financial players like Lloyd's Bank and Coinbase just went completely dark. So you have to ask, what on earth do all these things have in common?
Well, the answer is a single, absolutely massive company that acts as a sort of invisible landlord for a huge chunk of the internet. A company we've all heard of for sure, but whose most important business is one most people never see: Amazon Web Services, or AWS.
So what even is AWS? Well, put it this way. Instead of a company building its own incredibly expensive data centers, giant buildings full of computers, they can just rent all the computing power, storage, and other digital tools they need from Amazon. AWS is the foundation that thousands and thousands of other companies build their digital houses on top of.
And this is where the sheer scale just gets mind-boggling. We're talking about Netflix, streaming movies to 250 million subscribers, the entire player base of Fortnite, and get this, even Apple, one of Amazon's biggest competitors, spends over $30 million a month just to use AWS services. See, AWS isn't just another big company, it's the very ground that so much of the digital world is built on.
And if you need one number to understand just how big this landlord is, here it is, $108 billion. That's the revenue AWS brought in last year. It's the biggest cloud provider on the planet, and here's the kicker, it makes up most of Amazon's total profits. This isn't a side business. It's one of the most critical and profitable pieces of infrastructure in the world.
So it makes sense, right? When the landlord's plumbing bursts, every single tenant's apartment floods. Now let's trace that digital fault line and see exactly how one problem created this massive, cascading meltdown.
This timeline here is straight from Amazon's own status page, and it tells the story. Right after midnight West Coast time, engineers notice increased error rates, just blips on a screen. Within an hour, they confirm it's a real problem, hitting multiple services. By 1:26 a.m., they've narrowed it down to a huge database service called DynamoDB. And then, finally, many hours later, they find what they think is the real culprit.
And this is where the digital earthquake started. A massive complex of data centers in Northern Virginia, known as US East 1. Now, you got to understand, this isn't just a data center. It's one of the most important digital crossroads for the entire global internet. It's a huge nerve center.
Okay, so what in the world does this techno jargon actually mean? Let's break it down. Think of DNS as the internet's giant address book. When you type in a website, DNS looks it up and finds the computer's actual numerical address. DynamoDB is the name of a massive, supercritical database where tons of apps store their data. The problem was, the address book entry for that database just broke. No one could find its address. And if an app can't find its data, it just stops working.
A failure this big really forces a fundamental question on all of us. In a world where we expect everything to be online all the time, 24/7, how do you actually achieve that? What is the true cost of perfect, uninterrupted service?
The key metric everyone in this world chases is something called availability. It's really just a simple percentage, the amount of time a service is working divided by the total time. The goal is always to get as close to 100% as you can. But those last few decimal points, going from 99.9% to 99.999%, are incredibly hard and incredibly expensive to get.
And availability really boils down to this constant tug-of-war between two things. You got MTBF, mean time between failures, that's how long you can run before something breaks. And then you have MTTR, mean time to repair,
which is how fast you can fix it when it inevitably does break. You see, you can't just focus on preventing failure, you have to be absolutely obsessed with recovering from it in an instant.
So the obvious solution seems to be, hey, don't put all your eggs in one basket, right? Just use multiple cloud providers, AWS, Google, Microsoft, all of them. The promise is that you'll never have a single point of failure again. But the price for that is astronomical. It basically means you have to build and run your entire service twice or even 3 times. It doubles your costs and makes everything way more complex. It's a really tough trade-off.
This kind of leaves us in a tricky spot. If relying on one giant company is risky, but building on several is just too expensive for most companies, what does the future of our surprisingly fragile internet actually look like?
Well, one path people are talking about is government regulation. You can imagine rules that force companies to be more transparent about outages, or maybe even set reliability standards. You could even make it easier for companies to switch between cloud providers. But the big risk, of course, is that if you regulate too heavily, you could end up slowing down the very innovation that built all this stuff in the first place.
And this quote right here, it just hits the nail on the head. It gets to the very heart of the problem. A few hours of downtime for a video game, it's frustrating, sure, but life goes on. A few hours of downtime for a bank or a hospital's IT system, that's a full-blown catastrophe. There's just no one-size-fits-all answer for what's an acceptable risk.
And that really leaves us with this fundamental choice. Our entire digital world is built on just a handful of these foundational companies. We demand perfect reliability, but that reliability comes at an incredibly steep price, in dollars, in complexity, and maybe even in the speed of innovation. So the question isn't if the internet will break again, it will. The real question is, how much resilience are we truly willing to pay for?